All right, this is our breakout session. This is going to be very light on the graphics and everything else, and a lot on the interaction. I need you to interact with me on this. I'm going to kind of provide some guidance to make sure that we stay within the curbs on the street, but we can wander a little bit. The only thing that I'm going to ask you to do is, a lot of times when I get into these kinds of sessions, I know a lot of folks are saying, well, hey, I'm thinking about putting solar on my home, and I want to keep this focused on the campuses if we can. I'll discuss residential after we get finished, okay? Breakout session number 1. Here's what I would like you to do. I want you to be able to put this information even on a piece of scratch paper. I want you to spend some time and go down through this list and come up with some answers on your own, because individually, by tables, I'm going to ask you to come up and at least give kind of a quick thumbnail with your answers to those questions. Anybody have any questions at this point? This is kind of an open, interactive, talk to each other and holler at me if you need help. Okay? Let's go ahead and get started. I noticed a kind of a general common set of themes on some of these points amongst everybody. If we just view you as a common family for just a moment. Everybody's at least thinking about solar, obviously in part because you wouldn't be here. But when you look at it, there was a couple of points. I'm going to take these a little bit out of order. Believe it or not, although 2 and 5 appear to be the same question, they're not. One plays toward your facility, and the other plays toward the community and the campus and the students. Let me give you some examples here. Number 1, everybody's interested in reducing their energy consumption. That was a kind of a common theme. The school day, if you look at the plot, and I did this, I actually took a school district. I'm working with one out west of Fort Worth, and I plotted it out, and their energy consumption reached kind of the highest point in the midday and then trickled off as the students went home. Solar energy, solar panels facing kind of to the south follow the exact same curve. So solar produces energy almost identically in the same pattern that you, as an educational institution, consume it. So it's a very virtual, perfect fit for your kind of an operation. It's not true in all cases. But for you guys, you are an ideal candidate in that sense. Now, there's another technical thing I was hoping to hear, at least from maybe some of the energy managers. Part of a utility bill is what's called a demand charge. That means when you turn on something, you sit at home and the air conditioner comes on, either it's your home or someone else's, and the lights dim for a moment. It takes a lot of oomph to get that air conditioner started and then back up again. Well, if you have a central plant, for example, on your campus, and it's providing chilled water or other services to the other buildings, when those pumps come on, or the compressors, whatever you're using, there's a momentary spike in that electrical consumption, and it could go way up and then back down again, and you get nailed for that. How many people know here? I got a man shaking his head, yep. How many of you are at least aware of what is called a demand charge? Okay, a lot of you, good. We don't know what that peak is going to be, but for the most part, solar is going to be producing some, and it's going to take whatever you're consuming and reduce it by that much, and that peak, whatever it would have been, is going to go down by the same amount. So it can reduce demand charge, and demand charges can be a substantial percentage of your utility bill for the campus. Stabilizes electric costs. In other words, you're preloading. We're going to pay for the electricity by buying the solar equipment right up front. I'm going to buy it, here it is, but I've paid for it for the next 25 years. That's a common question. How long do solar panels last? How long does the solar equipment? Short answer for me is I don't know. It's gone longer than anybody ever predicted. We're now saying 25 years. I got equipment that's 40 years old and it's still working. Now, does it ever wear out? Yeah, eventually. I know people say, oh, I'm worried that it's going to get obsolete. No. Don't have to worry about that. It does eventually slowly taper down like about 0.5% per year compared to new. In other words, if it's here when it's brand new in its energy output, then after 10 years, it's down about 5%. You'll never see it. Because as we go along, we're changing out our light bulbs with more energy efficient styles. We're improving the air conditioning systems and so on. So you can still be saving in those areas as well. So it stabilizes because if you amortize out the cost of what you paid for that system out over the life of the system and the energy that it's produced over that life, you're paying the same in 20 years as you're paying right now. It doesn't go up or down. So as an institution, you're going to be paying at least that portion of your bill with the solar, and it's going to have a consistent cost every year over the life of the system, and that has value to you. You need a microphone if you got a question. I'm sorry.
What is the efficiency of the solar panels? For example, if I have a 350, well, I convert 350 to 102.6 watts per square feet. That's energy from the sun. What is the efficiency of the conversion from that energy to electrical?
Okay, the question, what is the efficiency of solar panels? I can actually give you a real simple summary on that.
Okay.
Typical panels today are in the 15 to 20% range, and that sounds horribly low. But your automobile engine isn't a whole lot better. If you ever go back and do the math that, okay, how much total energy is there in that little drop of gasoline and how much motion did I get from it, you're only getting about a 35%, give or take. 65% comes off the car as heat and everything else. Solar panels aren't that far behind. The good news is they have no moving parts. They don't wear out. Efficiency is kind of an overblown concern. Unless you are incredibly cramped for space, if you've got room, and goodness knows, looking at your rooftops, you do, you can buy a solar panel that has a slightly lower conversion efficiency. It is not meaning that, hey, that's a lower quality solar panel. In order to get that highest efficiency, it takes a lot more technology. Doesn't mean it's going to last any longer. It's just a lot more expensive. So, give me an area where you're really limited. Satellites. Satellites only have a finite amount of space. Look at the International Space Station. They could only make them so large. Okay, there you're going to strive for the best efficiency you can because real estate is expensive in those applications. For us, 15 to 20%, that's kind of the general range. There are a few that are slightly higher. Yes, sir.
Yeah, I just actually wanted to add to that because I've had people really lock down on that, 15 to 20% efficiency and like, wow, that's really lousy. I think the thing to think about, though, is when you have an inefficient thing like a internal combustion engine, which, again, is not very efficient at all. People don't realize that. It's the power in the gas that gets converted into actually moving the car is
pretty dismal.
Low. It's very low. But in that case, there's actually a lot of negative things associated with that inefficiency. I mean, and I won't go into all that. The reality is, when I think of the efficiency of a solar panel being at 20%, it's, in my mind, it's actually 100% efficient because it just is generating what it's generating, because it's not impacting anything when it generates it at the rate that it's generating it at. And I also want to add that plants are 0.5% efficient in terms of what they convert solar energy through photosynthesis to power to the plant. It's only 0.5%. So solar panels are actually pretty darn good.
Thank you. You're hired. And I want to kind of expand on what you just said. There was a concept that says, okay, what about the return on investment? I realize that people equate efficiency with quality, I need you to separate them in this case. Here, a higher efficient panel does not mean that it's a higher quality panel. It uses different technology. That's all. The life expectancy, we weren't even worried about efficiency when this one was made. And yet it's still working. Yes, it's down a little tiny bit. It was rated to produce 33 watts when it was new. It's producing about 30 watts under ideal conditions today. What is that? That's about enough to charge 6 cell phones simultaneously. It's not very much. Today's solar panels are much larger. I mean, we've got them in the hundreds, 300-400 watts or bigger. They've just gotten larger, but the efficiency has improved through technological changes that we've incorporated. Return on investment, I'm just going to ask you a simple question, especially for any of you that get the utility bills. What's the return on the investment right now on your utility bill? So anything that you get in the solar is an improvement. One of the things that a lot of people look at is the return on investment. I hate the word payback. Yeah, it gets into accounting and everything else. Don't worry about it too much. Typically, you look at it, what's the return on investment on your air conditioners? On your parking lot lights? There isn't any. Solar is the only technology that provides you a return. And if it's 10 years, that's a lot better than anything else you're plugging in. Okay. Possible net zero, it's hard to achieve unless the building is constructed and designed and constructed from the ground up to be super energy efficient. To their credit, Lady Bird Middle School has what's called geothermal air conditioning and heating. It's where you go out and drill a lot of holes and put the pipes in the ground and all that. The company did it right. I've heard a lot of horror stories about systems where they did it wrong. Now, there's a friend of mine sitting here in the room that is about to know which system I'm talking about. There was one system that was installed. It was low bid, like many of them are. And it just finally died completely. And money that was earmarked to put solar on a facility suddenly got sucked away and put into replacing the entire geothermal system there. It's not that geothermal systems were bad or are bad. It's that that one was not installed properly. And now to make matters worse, it wasn't repaired properly. So you do have to be careful. Anyway, net zero can be achieved, but it's a hard goal. I don't recommend schools go for net zero, means it produces as much as it consumes. Simply because it is such a lofty goal to hit. It's expensive to do it. We already know that. Irving managed to achieve it at Lady Bird. Look at reducing. I'm going to go back to a tiny story real quick. In 1993, I was sitting in Eugene, Oregon. I was at that time still in the solar industry. I was I was doing some technical editing for a solar energy magazine. And I was sitting there with the wife of the publisher and 3 of the staff people for the magazine. We're in these little squatty lawn chairs that are about a foot off the ground. And we have this new little item. It's called a sun oven. Little box with a glass front and everything else. And Karen, the publisher's wife, was cranking out a big vegetable stew and had what they called the Corel livingware. It was clear glass, but it was smoky color. That was called the Corel smoke. And you can look down in there and see it bubbling. And some guy, I swear he could have been a linebacker on any pro football team, walked up and kind of gave us this folded arm little attitude. And he looked down at Karen, who might have been about 95 pounds dripping wet. And he says, "What do you do when it rains?" And without blinking an eye, she looked back at him and said, "I used some of the propane I saved when it was sunny." And I have plagiarized her comment ever since. Solar can be supplemental. It just means that we use less of what we're consuming now. And where is it coming from? Nuclear, natural gas, coal. Around here we don't have real hydro in any kind of quantity. So it just means that we're using less of what we're consuming. Yes.
Hey, I wanted to add some things to this, if that's okay, reasons to go solar.
Absolutely. That's why you're here.
And one of the comments from our neighbors at the table back here was that there is currently a trend with incoming college recruits looking at what are sustainability initiatives going on, how efficient are your campuses, are your facilities. And so I think one of the reasons to go solar is the fact that there is a study out that talks about a large percentage of incoming freshmen are looking at that when they're choosing schools. So outside of the fact that it does all of these great things for electric costs, as you start talking with your campus leaders, one of the things that you can start talking about is it is going to affect your bottom line. It is going to affect how many students come to your college versus your neighbor's college who has already started to do these types of things, as well as looking at net zero. That is actually, we're going to talk about that this afternoon. I'm not the expert on that, these folks are, but I'm going to push back a little bit and tell you it's actually not that expensive to go net zero from ground up, but they'll get into that.
Not if you do it from the beginning. Trying to do it with an existing structure makes
Sure.
it a lot harder.
So one of the reasons to go net solar also is it will eventually, to go solar, is that it is going to start affecting the bottom lines of these schools, and that is where administration can really, dig their teeth in and say, hey, this may be more than just, a luxury. Back to another question you had, this begins to become a necessity. So,
I think we're there now.
I agree.
Everyone hear his comments? Thank you very much. Excellent, all the way around. It's doable. As I said, it's doable as long as you do it from the beginning. You got to hire an architect that's aware. He's energy efficiency aware. Get somebody that's from the United States Green Building Council, USGBC. There are people out there that are energy aware and not just concerned with how cheaply can they make the building. What's astonishing to me is I've had, over the course of my career, an opportunity to meet a lot of contractors, both residential and commercial. And to build efficiency into a building is actually very little cost. What they're looking at is, though, if they can sell a building for $1 million and it's cost them, and I'm going to grab a number, say $20,000 to build some efficiency into the building, that's $20,000 out of their pocket. And if they don't have to do it, they don't do it. And yet that turns around and that may save you many times more than the $20,000 over the life of that building. Curriculum expansion. These are just a few that came to me, and I know there's more. You can get people involved in accounting, energy, data acquisition technology, meteorology and weather. How is the system performing compared to the weather? Little odd thing about solar panels. Everybody thinks, oh, they're going to do better when it's hot. No. If you had a choice between working outside in your yard when it's 65 degrees or when it's 105, what's your choice? Solar panels are like people. They work better when it's cold. The cooler it is, the more energy they produce. The difference is that in the summertime we have longer days, so you don't see it as much. But weather, astronomy, tracking the stars, tracking the plots of the sun, architecture, energy efficient design, math, science. I'll tell you what, I hated math when I was going through school. I mean, that's like saying I'm a pre-med student and I hate the sight of blood. And now I'm using some of that math and I'm glad I at least got it. Now, there's two items here that I wanted to call to your attention real quick. I realize that one is for high schools, but you come into contact with high school people. There is an organization that was founded here by Dr. Lehman Marks, formerly of the Winston School, if you're not familiar with it. It's a special school for learning challenged children, kids with ADHD and so on. He started a program about 25 years ago now, where he discovered that a hands-on project for the kids got them learning in ways that sitting in the classroom didn't. That program has now been internationally recognized. It's based here in the Dallas area. And it's a program where high school kids design, build, and race totally solar-powered cars. No gasoline engines, nothing. Solar panels. Some of them have batteries on them because the solar panels charge the batteries so they can go uphill and down and so on. It's out there. It's called, it's the solarcarchallenge.org. The other one plays right into your domain, and that is something called the Solar Decathlon. Colleges and universities design and build energy-efficient homes. Let me show you a couple of pictures. This is from the Washington Mall, Washington, D.C. Now, this is before it opened. That sidewalk was absolutely wall-to-wall people after it opened. They get about 500,000 visitors every year. Now they started moving around the country, but for years it was held in D.C. Look at it. Can you see the people? Every one of those is a house. Every rectangle, whatever you see, and it's international in scope. They've had entries from Europe, Asia, South America, Africa, the Polynesian countries. These kids bring this stuff in. How they get it here is not, I don't know. But they get it here and they build these houses, and then whichever one ends up being the most efficient, and this is specifically for colleges. It's every other year, so you got ample time. Take your freshmen coming in, get them started. At the end of their sophomore or second year, hopefully you'd have a project that they could do something of this nature. But you look at the openings for curriculum opportunities that this also now presents. Do we have any questions? Okay, this is going to be a broad ranging of topics then. This is the instructional side. Let's see if I can get through this fairly quickly. But there are some key points in here. How many people are responsible in this room for making the purchasing decisions? There's several of you. Well, this is going to play into your field, but it's also something that the others will learn and take back to their respective campuses and colleagues and so forth. Discussion points. These were questions that were funneled to me. What kind of solar panels are best? My simple answer is ones that work. All kidding aside, solar panels, if we have been in the market long enough now, companies that have been around for at least 10 years. We've got several companies now that have been around longer than 40 years. So if you're looking at somebody, you've never heard of them and they've only been around for 2 years, at this point I would pass. You'd say, well, how are they going to get started? I'm making an investment that needs to be around for 25 years. I'm not sufficiently confident in somebody else's product to know that they're going to be here in 10 years to support it. Some of the companies have been around long enough to do that. Problem that I ran into is that, some of the questions that were asked, I said, well, define best. What does best mean? Who makes the best solar panels? What does best mean? I'm going to open that up kind of, and then I'll repeat it so that it gets into the video. But real quick, if somebody thinks, what kind of panels are best, what comes to mind? Just holler something out.
Longevity.
Well, longevity, all right? Longest lived panels. What's another one?
Plastic used that you said discolored on those older models.
Okay, they don't do this anymore. He said the packaging and everything else, they don't discolor anymore. This was something early on, and it was the plastic. It did not affect the panel, just the visual.
Hail resistant.
I'm sorry?
Hail resistant.
Hail, we don't get hail. We get bowling balls. Now, that's actually a topic coming up, but I'll answer that. Hail resistant. Let me tell you right up front. How many people are aware of Underwriters Laboratories UL? They are the organization that kind of acts as the librarian for most of our safety standards, whether it's electrical or fire or anything else. They do not write those standards. Those standards are written by very highly qualified groups of individuals that they call a standards technical panel, or STP. In the solar industry, we have two primary standards today, one for the solar panels and one for the electronics. I'm on the electronics panel. I'm one of only 68 voting members in the entire United States that helped craft that standard for our industry. UL vetted me for 2 years before I was admitted. So I'd say their processes are fairly rigorous. When we look at solar panels as part of that safety standard, one of the things that it has to pass is they literally take the equivalent of a 1-inch hailstone and they fire it right at the center of that solar panel at 55 miles an hour. And if the glass breaks, it fails, obviously. It's tempered glass. Will hail break solar panels? Simple answer, yes. Easiest way is, hey, if the hail is large enough to break out a back window in a typical sedan, it's large enough to break the glass in the solar panels. These are made with tempered glass. So if a hailstone smashes a solar panel, what do? Same thing as when it breaks the windshield on your car. You replace it. Does insurance cover those? Check with your insurance company. I found most will, and I found a few that won't. So, hail resistant. Give me some more. What does best mean? Yes?
I'm just curious, how many times have you seen broken panels from hail?
Oh, geez. How many times? Well, understand, I do forensics for the state of Texas, so mine would be skewed toward the high end. Several.
Okay.
But usually, let's rephrase that and say I've had solar panels on our home today and in other states. Up in Wisconsin, we get monster thunderstorms up there too. My personal experience with solar panel breaking, 0. And yeah, we've been through some pretty monster. I got dents in my automobile to prove it, but my solar panels are intact. Now I'm going to go back. I keep harping on Lady Bird Middle School. They had solar panels in an area of their roof that was hit by grapefruit-sized hail, and they discovered it was cheaper to replace the solar panels than to have to repair a roof area that was not covered by solar panels. That I found very interesting, and that came from their facilities manager for the district. Best, I mean, it means different things to different people, but you want to be able to put it up and not have to worry about it. Yes, sir.
The one factor that plays into best is your risk assessment and your comfort with risk. And by that, it could be that thing is tried and true, proven technology. Maybe that's where your comfort level is. Do you want to be out on the leading edge, the bleeding edge, the R&D side of it? So that's part of it, is your own risk assessment model. I can't risk giving credit where credit is due. You've mentioned Lady Bird Johnson 4, maybe 5 times. I think I heard a gentleman mention he was from the DISD. Was there somebody here from the DISD?
Who's here from Dallas?
Maybe
ISD?
not. Maybe not.
Garland?
Okay. Oh, Garland. I'm sorry. Here's the dot that I want to connect. The fella behind Lady Bird Johnson was Scott Lane. Our champions are not invisible. We should know who they are. Scott was a true champion. He's now with the Dallas ISD, and you're going to see an awful lot of emerging renewable energy coming out of there because of Scott. So we'll give credit where credit is due to Scott Lane. Thank you.
Thank you. Good comments. Well, when you look at it, what kind of solar panels are best? All kidding aside, we have about 20 companies now that are long-lived, have had consistently good track records in their product. And when you talk about risk assessment, have we had fires? Yeah, and you know what? Almost every one of them tracks back to an installer that screwed up. Has a solar panel in of its own accord failed? Yeah, rarely, but they do fail. They've got electrical parts in there. Fortunately, there's not a lot of combustible material there. But that doesn't mean you can't have fires. One of the worst fires occurred out in Bakersfield, California, and it turned out to be an installer error. So, there are about 20 companies. We've got one right here in San Antonio called Mission Solar that are making some darn good panels. CPS Energy in San Antonio, municipal utility installed. 600 million watts, and that company made every panel. And so far, and at least, and I've talked to people inside CPS Energy, they have had 0 failures. That is not to say that certain panels that were installed prior to theirs didn't. They had a hailstorm that went through and it demolished a huge number of panels, and they got to looking and they said, and to the question about hail, all of a sudden the emissions were all intact and the ones over here from a cheaper company weren't. So CPS said, rather than replace these with what we had there, mission, well, you come in here and put yours in instead. That speaks volumes to me. Who offers the best value? You know, this is hard to say because a lot of the costs are in the installation. A lot of this kind of gets buried. My suggestion is don't necessarily go with low bid. I used to work in Europe and I love what they're doing over there. You solicit a quantity of bids, average them all together, and whoever's closest to the average gets the job. Remarkably simple. I looked at it and said, okay, you're not getting screwed, and they're making enough money to do the job properly. Win-win. I know law says you got to do low bid and you get what you pay for. Same thing applies in solar panels. The cheapest solar panels that we're getting right now are coming out of Vietnam. I had the good and bad fortune of going down to Puerto Rico several times after Hurricane Maria struck. Solar panels, I saw stacks and stacks and stacks, and they were almost all Vietnamese. Well, they were cheap. And they got sucked out of the frames by the wind. It literally came through like a vacuum cleaner. So I designed some systems free of charge, put in months of my time, little bits here and there. They're installing systems down there. I specified the missions because they're good for 175 miles an hour front or back, standing vertically in a wind. I got the lab test, but I'm sworn to secrecy on that. I got a non-disclosure agreement. I can't let them out. But I've seen it. So when you look at best, don't necessarily go with the cheapest. You don't have to go with the most expensive either. Get a company that's been at it for a while is generally my best advice in that regard. There's not a huge difference in efficiency and quality. Please don't equate the two. That is not the case. Average cost of solar panels today varies. It just depends on what you're working with. That little solar cell that I had here in my pocket, I paid the equivalent of about $760 a watt. Today it's about $1 for the same energy. So these have come down more than 99% in the last 50 years. They're like calculators. The first calculator I bought was $400. I can buy the same function today for $1. Is it the same quality? No. It's got throwaway batteries in it. But solar panels are only a small part of it, so don't go on the basis of the cost on the solar panels. You got to look at the entire system, and every installation is different. So there's not any one singular, this is what it's going to cost to install. Generally, we can look at a very broad range and say between $2 and $3 per DC watt. So if you put in 100,000 watts on this building, you can kind of think of it as being somewhere between $200,000 and $300,000. But there are incentives, and it does have a definite return on investment. One of the requirements, for example, by the city of Dallas, I say that because we're sitting here. 10-year payback, as they call it, 10-year ROI or less. We just squeaked in under that. Average cost of a system, I don't know. How much does the house cost? There is an average cost of a system, and there's an average cost in dollars per watt. I just gave that to you. What did you say the dollars? Generally, and this can vary. Don't take this as, oh, hey, somebody said it was $3 a watt tops, and you're $3.10. There may be some mitigating circumstances, but typically between $2 and $3 a watt today, DC. In other words, if the solar panels are rated 100,000 watts, $200,000 to $300,000 kind of number. Can it vary? Absolutely. That's why you get this, your mileage may vary on the window sticker on the car. What resources? There's a bunch. I gave them to you in the previous session. There's a mountain. Just be careful who you trust because a lot of these may or may not be accurate. Go to places that are known. The North Central Texas Council of Governments has done a marvelous job of putting resources together for folks like you. Go Solar Texas is the website. Conduct an energy audit. This is something that McKinstry, I will hope, mentions at least a little blurb. Have somebody come in and look at it. Now, most of you, if not all of you, are probably on power lines that are serviced by Encore. Not mean that that's who your electric company is, but Encore owns the wires. They also track utility consumption every 15 minutes, and that's available to you free of charge. Now, as it comes back to you, how many people here are reasonably spreadsheet savvy? A little bit. You know what a comma-separated variable file is, where you got the number and a comma and a number and a comma and a number? They'll send it to you that way, and then you can bring it into a spreadsheet. Well, as it's given to you, it's like, raw vegetables. You got to cook it. You got to do things with it. I've got software that I've written. You could have done another PhD on just that one spreadsheet alone that completely analyzes it. There are others that will probably have the same thing. Get your free 15-minute data. Look at what your usage is. Get an audit. Find out where your holes are. Fix them. Schools are a big block of Swiss cheese. They're not tight. Air going in and out, doors open, closing, kids leave doors open, lights on. Okay, we can take a look at your general usage. Act on the recommendations in an audit. Fix the leaks first. You can get independent solar recommendations based on the results of that work up front. What am I doing? I'm putting me in the solar industry second to the folks behind, here at McKinstry and others like them. You get an audit first, find out what you can do, because it's always cheaper and more effective to immediately fix the worst energy offenders than add solar. Don't do it the other way around. Yes, ma'am.
And if I can just let our guests know that Dallas County Community College District went to SECO, State Energy Conservation Office, and they did 3 free preliminary energy audits for us, and we're getting ready to do detailed energy audits at all of our colleges. And so thank you. We are planning to do that. And so if your college or ISD does not know about it, go to SECO and ask them about their energy assessment program, and you can get free assessments.
I'll tell you right up front.
Preliminary.
Go ahead. No, SECO is a great bunch of folks. They're down in Austin. The man you'll be dealing with heads up that program. His name is Dub Taylor, but he's got an incredibly good staff as well. Go to their website. Problem is, there's so much information you get overwhelmed and you don't even know what you're looking at. I get it. Okay, once you've got that and you got some basic recommendations, let's say from an engineer like me or somebody else, then you can issue a request for proposals, not quotes, just what will you do to help answer our request. And don't deviate from somebody will come in and say, don't deviate. Hey, I know I said to do this, but hey, you want to buy a watch? Honest, it's a Rolex. It says Rolex right on it. Okay. Don't deviate from what you got from the independent engineer. They're going to try to sell you what they make the most money on or what they know best, and it may not be the best for you. The usual. How long have they been around? How many similar systems have they installed? Do they have their own crew? I know a lot of companies that don't have any employees, and they hire out as needed. No thanks. What licenses and certifications do they have? Now there's also an abbreviation there. It stands for the North American Board of Certified Energy Practitioners. It carries absolutely no weight at the state or federal level. It's just an additional certification, and people that go out and get this NABCEP certification have done so on their own. So it shows a little bit more motivation. They've been through some additional schooling and testing. It's just one more item that helps show that they've had better experience than somebody that doesn't. Take a look at feedback from existing customers, and just because you got let's say, and I use it as an example, I've seen instances where a company had 4.5 stars. You think, wow, hey, that's pretty good. And then I looked again and said, well, there's only 2 reviews. One was 5, one was 4. Then I dug a little deeper and I found one was posted by an employee for the company. You can't trust it. So you issue the RP, don't deviate. NABCEP, I'm sorry, I didn't realize I'd gone backwards. Don't put too much weight in the reports that you get. Look at the reports. Another question, does the same company that install also do the maintenance? What happens if a solar panel does get broken by a big grapefruit-sized hailstone? Who fixes it? Make sure it's the same people that installed it. Now, the unusual, and if you take nothing else away from my presentation today, you look at immediately under first and foremost. This requires no skill on your part and infinite skill on theirs. It means they understand solar well enough to translate any aspect of it into plain English for you. And if they can't do it, they're not qualified. It's that simple. Leases are generally no longer a worthwhile consideration. Take a look at the warranties and see who fixes it. Just because they're a large company, and bankability is a term that's tossed around rather loosely in our industry. You were saying risk. You're talking risk. Risk avoidance, you got that in any product there is. It doesn't matter. When we start talking about risk, large companies do not mean that they're going to be around for a long period of time. Risk in this case, we've had companies like General Electric, BP, as in British Petroleum, Shell, Chevron Standard Oil, and others, big companies that have gotten into the solar industry and got out. Well, BP made some solar panels and turned out that after 10 years the solar panels are not holding up. So what are they doing? Well, they're refunding the money. Well, that's easy to do. What happens if you got to have 10 solar panels in a string and one of them's dead? Now your whole system is dead because the one can't, money doesn't do you any good. So you need somebody that can stand behind it. There are companies that will step in, and I'm seeing a number of them that are very knowledgeable, that are helping to support some of these orphaned systems where a company has installed it and then they've turned around and maybe gone out of business. So you're not without backup. It may not be the first phone call that you make, but there are people that will help you. Take a look at how diverse the solar contractor is. Take a look at their background. You're getting married for the next 10 or 15, 20 years. Some quick myths. Solar does not provide electricity if the power goes off. The only time it's capable of doing that is if you got batteries designed into the system, and most people don't. Batteries wear out, they add expense, there are other reasons. There are times when you can add batteries. I got a $27 million project going in right now down in Austin. Anybody else here from Austin besides our afternoon people? I got a $27 million project, solar project, that's got batteries in it. They needed the battery backup. They're doing it for other reasons. But for you and me, just for energy consumption reduction, you don't need batteries. But if the utility goes off, so does the solar equipment. That is a safety feature. It is required. Another common myth is that, hey, it takes more energy to make a solar panel than it'll ever produce in its lifetime. And that has been debunked more and more times. I was going to put a graphic in here, and I said, no. You're going to have to take my word for it. National Renewable Energy Laboratory, part of the United States Department of Energy, has assessed this time and time again. And the average time it takes to generate the equivalent energy that it took to make that solar panel from mining, refining, construction, manufacturing, everything is about 2 years. So I've had 38 years worth of free energy out of this one. Toxic, not anymore. There were heavy metals in some of the earlier solar panels like lead. Certain panels are still made. There's one company in Phoenix called First Solar that's making solar panels that use cadmium. If you get a broken solar panel or for any other reason, they'll take it back and they'll properly recycle it. Otherwise, if you look at the material safety data sheets, MSDS for these things, They're completely benign. There's nothing toxic in them. It's aluminum, it's silicon, which is window glass. It's, a few other things. There's some plastics and so on, but there's nothing that'll leach into the groundwater. It may be around in 100,000 years, but there's nothing toxic. Health risks, boy, I've heard all kinds of things. Boy, I don't know. The only health risk I find anybody around solar panels are the guys that lie about it. I've run into a few of those, and I'll tell you, at EarthX, I even walked up to a company, I said, you know what you're doing is illegal? And they said, yeah, but we haven't gotten caught. I don't know how to respond to those. Solar energy isn't economical. Well, it depends on your definition of economics. The short answer is it is today. I'm grateful because nobody in the outside world has discovered this to any large extent because we couldn't handle the inrush of orders if they did. I'm already putting in 80 hours a week in design and consulting and other things. My wife said, when am I going to retire? I told her when it quits being fun. To me, this is still toys. It's like when I was in 3rd grade and I got that experimenter's kit. Still toys to me today. How long do solar panels last? We don't know. What about hail? We discussed that. If it's big enough to break out the back window in a car, it'll break solar panels, just replace them. How many, I love this one. How many solar panels do we have to, this is a carryover from the radio show. How many solar panels do we have to put on our house to have a zero bill? My response, more than you got roof space. How much do they weigh? In average, maybe 40 pounds, give or take. Larger ones are about 45. What are they made of? Touched on that. Aluminum, plastic, and silicon, window glass, just manufactured a little differently. Oil turns into plastics, it turns into diesel, it turns into gasoline, it turns into all manner of other things. Just depends on how they manufacture it. Is efficiency important? Short answer, not today. As long as you go with a tier 1 company or somebody making prime quality solar panels, there's about 20 companies that are. Efficiency is not a concern unless you're looking at squeezing every watt possible from a system. But be prepared to pay for it. How much? Double.
Just quickly, I calculate 19 kilowatts per 1,000 square feet, factoring the 20%.
He calculates 19,000 watts per 1,000 square feet.
Per 1,000. That's like a rule of thumb.
Can you tell he's an engineer?
So for people who want to
No.
figure it out,
You know,
with 20% of
today people that buy cars don't care about compression ratio. Will it run? Will it run a long time? Is it safe? Is it reliable? Are solar panels expensive? Very simple answer, not anymore. Expensive is relative, but I will tell you right up front that it's cheaper right now. I mean, the costs are down about 90% from what they were 30 years ago. They are now affordable. If you were to go out and take out, let's say, a home equity credit line and then pay that back every month, your utility bill will generally go down by more than the cost of the payment on your credit line. You might be saving $80 and your payment might only be $70. Cloudy weather, yes, they do, just not as much as when it's clear. Do they make electricity? Yeah. Matter of fact, during this storm, I went out a couple of times, and like I said, I'm over on the west side. I'm about 3 miles from where that Fort Worth tornado came down. It was so dark at that point, the little LED light indicators on my solar equipment thought it was night and everything turned off. But it was 3 o'clock in the afternoon. Short answer, yeah, they still make some, just not as much. What if they get broken? Talk to your insurance company before you ever install them. Whoever insures the schools, maybe you're self-insured. That's a self-risk. For residential and commercial business, talk to your insurance company. I find about 80 to 90% of the insurance companies will insure solar. Last but not least, any other questions that I haven't covered? This is kind of a real general overview. Like I said, this was long-term. Yes? probably want to go to the microphone if you got a long question. Go ahead. Well, go ahead and get it on the video anyway.
One of the things that's been discussed and brought up several times is that, well, we can start and do something and then build on that. And the problem is that I've talked to a few people over the years that said, oh, well, I have some 150 watt panels I put in several years ago, and now the panels that are the most efficient are 350 watt or 400 watt. And, well, we can't tie those in series. They all have to be the same. Is that true, or has that become a myth?
Not if you're a good engineer.
Okay.
I've had many of those systems that came through with the older solar panels. They said we want to incorporate the old with the new. That comes down to that plain English thing. If they know it well enough to talk to you in plain English, they know it well enough to take care of the old and blend it in with the new. There are ways to do it.
Okay. So it depends on the expertise of who you're talking to. It's not, so that's a myth technically if the person knows what they're doing.
There will be some limits on it, but it's generally doable.
Okay.
So his question, could he blend the old with the new? Short answer, usually. I'm not going to say always, but usually, yeah, I've been able to do it. Any others?
I have more of a comment regarding the intrinsic value of like purchasing it. It kind of relates to what was said over here. And we had a number, it was 61% of college students make considerations for sustainability on campus. And I feel like it wasn't touched on in a positive way, at least a negative way. We talked about the aesthetic of maybe blowing out a patch of bluebonnets for a solar panel. I feel like not too many people regard like power lines on campus as, a monument of beauty. But I have seen students on my campus talking about and noticing the windmills we have and the solar panels, and I feel like there's something to be said about the aesthetic that they provide, especially with like the mosaic blue. I think that the draw that has for college students these days is a lot more than it was a bit ago.
Well, and to your point, when we start talking about aesthetics and everything else, I don't advocate mowing down flowers or cutting down trees. If you put them on your building, it's automatic shade. You spend a lot more money cooling than anything else. You're shading the building, you're reducing the heat gain. You're keeping it out away from everybody. What he's talking about, the blue, this is a solar cell. I used to pass them around and I'm down to one, so I can't. This is a solar cell. On the back, that's where they make the electrical connection here. The little lines on the front of it are the other connections, like having a flashlight. It's called a cell, but everybody calls it a battery, so I'm going to. You got the bump on one end and the flat on the other. That's one connection, that's the other. But you see, it's that nice mosaic blue like you saw on the slide. Others are a solid black. It's just a difference in manufacturing techniques. This one is slightly less efficient, meaning if I had one of these solid black ones, the same size, it would produce a little bit more than this one. This is a little lower cost. So this is what a solar cell looks like. I have got a solar panel. If we got just a moment, I don't know, is lunch here?
Lunch is here, but go ahead.
Okay, I will be very
7
quick.
more minutes.
I'm sorry?
I say you have 7 more minutes.
Well, and before I leave, during the lunch break, I want to make myself available. It's kind of a general Q&A. I want to show this to you after you've eaten and so on. Understand this little baby solar panel. I'm going to pass it around. I'm going to let you look at it. It's got all the parts. It's just tiny. Okay? It's itty bitty. Do be mindful. There are some sharp edges. Okay? These are normally not the kind of thing that you stick out where everybody can get at them, but this is a demonstration solar panel from Mission down in San Antonio. Good company. This is what they look like. I'm just going to let you guys pass it around. I'm going to start it right here and let it get around the room.
Excuse me, Don.
Yes?
Is the back box, this panel, is the converter?
No. The black box on the back of that thing is just where the wires are connected.
Oh, I see.
Now, here's an individual solar cell. I'm going to ask that you not lift up the plastic. Why do I do that? I went to a conference and I had somebody pick up the edge of the plastic and reach in and touch a solar cell and broke it. These things are thinner than a sheet of ordinary notebook paper. So that one's just to look at up close and personal inside the plastic. Now, one of the things that we talked about hot water. I'm just going to get a little tiny plug. This also is a little demonstrator. Cold water goes in, hot water comes out. We talked about efficiency. If you're hung up on efficiency, solar panels generally are around 20%. The rest of it comes off as heat, pretty much. Hot water collector. These are between 80 and 90% efficient, meaning 80 to 90% of the sunlight energy into this thing is converted into hot water. Just remember, it's not unlimited. That's all right. I'll tell you what, I got greatest daughter. They're both married now, gone. For you younger ladies here, and anyway, I just remember the last day. She said, oh, she's gone. Last one, empty nest, and then about 6 months later, she was like, she's gone. All right, this is a solar hot water collector. These are about 4 feet by 10 feet in real life. 2 of these will take care of a household if they're facing south. We get 100 gallons of hot water a day at 160 degrees. So she says, that's hot. I've got an anti-scald valve on it, so it stretches that 100 gallons into a lot more. Means the hot water comes in at 160. We got city water coming into that little, it's adjustable, and it comes out at about 125. So all of a sudden, my 160 degree water blended together suddenly becomes not 100 gallons, but probably more like 140 gallons at 125. Hot water isn't sexy. It can't be given to your neighbors when you got enough. But, and forgive me, someone said you're looking at solar hot water at your school. Who was that, please? Solar hot water has a better return on investment than solar electric. It does require plumbing. And it does require backup. But when it's working, it's even better than the electricity.
Are you seeing solar hot water for space heating or generally more for domestic hot water?
Am I seeing solar hot water for space heating? No. It's for what I call domestic consumption, meaning clothes washing, bathing, you know, on and so forth. I've got a facility west of Dallas that's looking at it for their laundromat right now, and I'm helping them with that. Any others?
So I'm sorry, Dan. You said 2 of these will be enough for
2 full size,
hot water for
4 feet by 10 feet when these are full size, and I couldn't lift it by myself. There's a lot of copper in this.
But is these coppers is only these 3 pipes?
Well, just no. This is just a demonstrator. There's many in the full size panel, in the full size collector.
There's like supply header and return header.
Yep. Go in, go out. Or like we say, gazina gazada.
So it's like this and this.
Yeah. Anyway, do you put those on a roof? Yeah, those solar hot water collectors go right up alongside the solar electric. They're heavy, but you know what? The weight requirement for roofs has been proven time and again to be grossly overstated. Matter of fact, an extensive study that was conducted at the University of New Mexico in conjunction with Sandia National Lab proved that roofs have about 300% more strength than the code calculates. So you've got 300% more margin than you realize for weight.
You said those are how much?
And how much? Well, solar hot water is different. It's really hard to say. Physically, they're 4 feet by 10 feet. It takes 2 for a family to 5 to 6. Depends on your hot water usage. If you've got a teenage daughter and she gets her friends over, then it lasts about 2 hours.